Hello guys, today we're going to start with the concept of slope. Alright, um, knowing what a slope is very important, very important to learn calculus. So as to learn calculus. Right. So let's begin. Slope. Let me just draw two axes, and let's say I draw a straight line that's passing through the origin. That's a straight line. It may pass through origin. In this case, it is. So it's passing through the origin, and let me mark some two random points. So this, let's say, the coordinate of this point is x1, y1, and the coordinate of this point is x2, y2. So this height is y2, and this length is x2, and same for this point as well. This is y1 and this is x1. So what am I doing over here? I'm traveling from this point to this point, so I'm going from this to this, like that. For this journey, I can actually take some alternate path. That is, I can first move from here to here, parallel to the x-axis, and then move upwards to go to the north, 90 degrees. So this is my first part, this is my second part, and I ultimately reach the same point. So let's just do the same thing over here as well. So that's basically a triangle, 90 degrees triangle, right angle triangle. And now the coordinates of this point. See, the height of this point, this height is just the same as this one, because this is parallel to this. So as this height is y1, because the coordinate of this point is y1, this height is y1, this height is gonna be y1 as well. So the y coordinate is y1, right? And what about the x coordinate? X coordinate is this horizontal distance. So what's the distance from here to here? From here to here, the distance is x2, right? Because this point is, if you have to mark this, the distance of this point from the y-axis, it's this, right? That's x coordinate, right? So x2 is this distance, so this distance is gonna be x2 as well. So there's x2, y1. So these are three basic points. That's our triangle, and let's proceed with the concept of slope. Right. So you may be seeing that we are making certain angle over here, and that angle is same as the angle this line makes with the x-axis. So this angle is same as this angle. That is, this line is actually making an angle of theta with the x-axis, because these two lines are parallel. Okay, so it makes an angle theta. Right? So indirectly, a line is actually making angle theta, so it's kind of inclined, right? It's not parallel to x-axis, it's inclined with x-axis, right? That's just from previous video. Yep, it's inclined. So let me just draw this again. Okay, just line, and that's inclined. x2, y2, x1, y1. Okay. Now, if I have to say that at what angle is it inclined, can I ever find it out? Yes, you can, of course. This is a triangle, isn't it? So this point was x2, y1, wasn't it? So this point is x2 y1, this is x1 y1, this is x2 y2. Now the most important thing, right? Most important thing is, if I have to find out theta, I can use one of these three trigonometric ratios, because I know the lengths, and if I know the lengths of the sides of triangle, I can know the angles as well, because these trigonometric ratios actually link the angles to the lengths, you know, this something about something is linking two sides with a certain angle. So I know this because I know the coordinates. So I can say that tan theta is known. And what's that tan theta? It's opposite side upon adjacent side. And what is the opposite side? See, this line is perpendicular with the x-axis. So this, we have to know this height, right? And the initial height is y1, the final height is y2. So the change in height, if you are traveling in this direction, y2 minus y1 is the required length of the side, isn't it? So opposite side, that is y2 minus y1. Now the adjacent side. Adjacent side is parallel to x-axis. So the only displacement is in x. Here the only displacement was in y, because there was no displacement in x. It was perpendicular to y. So it was only getting displaced in y-axis. So we could easily subtract y2 minus y1. Here we can easily subtract x2 minus x1, as there is no displacement in y. It's just horizontal. Here it was purely vertical. So this is x2 minus x1. This side is x2 minus x1. So this is gonna be x2 minus x1. And sorry about that. X2 minus x1. So that's how we find tan theta. But we need a theta, right? So many of you may actually know what an inverse trig function is. That is, inverse trig function is simply this: sine theta is, let's say, equal to x. Then if I have to say what a theta is gonna be, I can easily write this as theta is gonna be equal to sine inverse of x. I just inverse the function. If you don't know what that means, don't worry. I'm just we won't be using it until later, and at that time I'll introduce to you the function of inverse functions as well, and the concept of inverse function as well. So we can write it as tan inverse of y2 minus y1 upon x2 minus x1 is actually equal to theta. So that way we get theta. We don't have to actually worry about this for a moment. No, let's just cancel it. You don't worry about it. No, this is what is most important. Tan theta is y2 minus y1 upon x2 minus x1. So that's the concept of slope. Slope is our tan theta, right? Slope is our tan theta, and that is opposite side, that is y2 minus y1 upon adjacent side, that is x2 minus x1. So that is what is y2 minus y1? That is change in y coordinate upon change in x coordinate. How much did you move on y? Let's say you travel from this point to this point. Okay, how much did you move on y? Let's say I moved delta y. How much did you move on x? I moved delta x. So my slope, that is my tan of theta, is gonna be delta y upon delta x, and that way you can find the angle. What's the inclination? You can find that. You can find the angle. Right? So that's the significance of slope, right? And that's very important, and This is what we're gonna use while deriving or while learning calculus. Alright. So that's it for this video. I'll see you on the next. Thank you very much.